No one's really looked for it. They've been having tests, so.
For interruption, staff and students. This morning we're going to be conducting our first fire drill of the year. Please listen carefully as our procedures have changed.
I guess it's good. We're not having a test in here. So.
We will not be using the alarm system to alert you of fire drill. Instead, we'll be doing it through the announcements, and we'll be doing the drill in 2 waves. We'll have one half go outside and complete the drill, come in, and then we'll do the second half. So while one is out, the other people can be having normal class time as usual. We're going to start with the odd numbered classrooms in the building.
Dang it, that's me.
Students, teachers will direct you what you need to do.
Last person
Students,
out.
you are to wear your
open.
mask the entire time throughout the drill, maintain your social distance. Include outside, keep your mask on when you're outside. Thank you for your cooperation. At this time, odd number classrooms, please follow your fire exit routes and exit the building. Thank you.
I'm sure there's a couple fires. Yes. Bro, I went into the run a state. I was like this one. On different planets.
Oh, you don't say that, you know, even if you like say that right now. Right. Oh, yeah.
We're live.
38
So whenever we have fire drills, well, I'll show you what I think of.
We get inside the fire, show them to realize everybody coming to the building at the same time. 6 out of 7 periods. We're all not.
So yeah, survival, social distance, people.
Yeah.
Oh, wow.
Obviously.
Why don't they just start like an actual fire to see if we are prepared?
Actually, they're being
Burn down half the school.
That's a good idea.
Yeah.
They burn down like a week or two.
So this is what I always think of when we have a fire drill. No. Right? Love this song. So I had a project.
Classrooms, it should be the even numbers, to any classroom or any student or adult that does not exit the building. Please do that now, follow your fire exit route. Thank you.
I had a project one time, and we were supposed to like create a song or do an artwork or something like that. So what I tried to do was I tried to like list chemical like atomists into like a song, and like so I would like sing about Rutherford, Dalton, Bohr, all of them, and I put them in a song like this with this beat. It's pretty good. Nope. It was ugly.
It's on YouTube somewhere. We gotta find it.
It's got
Is it on the show?
Mr. Bauer doing subscribe and.
For my classes. And actually, so I'm currently in a doctorate course at Liberty, and I had to create a video, and we're working on editing videos, and what I did was I cloned myself. And then I thought, like, it's on my Springboro account, so like anybody who follows my videos will see how terrible that video is.
Can we watch it?
No.
Come on.
We can be your audience for that class.
Constructive criticism is good.
You know what's better than one plum? 3 plums. I think we double that again, add some reverb, make it an opera.
Now it was all right. I'll show a short clip.
Okay.
Short clip.
What's your YouTube revenue?
I forget honestly.
It's too much. He does this.
Are you talking by the second or by the minute?
Second.
Oh.
Like we talking $100 per second?
I mean, I had more zeros than that.
Because this is just your hobby.
On which side of the one?
Left side. All right. This is my video. Don't judge. It's supposed to be silly.
If we laugh, we promise it's with you, not at you.
I tell him it's worth it. I will do it.
Oh,
Put on my lab coat for this.
It's a brand new one. This is 5 minutes long.
Yeah. It took about anybody have nope. So cheesy because I'm talking to a computer.
More next.
They're both AP Physics. I need 2 of them.
it's amazing.
That is solid. That
That
is
is
good
solid.
right there.
I'm gonna watch football. I don't know.
That's what I do.
So I tried brushing this line as best I could. It's kind of hard. I had transitions all that.
They need to start this.
Clearly not. Where's the face mask?
Yeah.
Yeah, lose the top of the arm.
It was hard, all right?
This is awesome. This is like
Do that.
Then I had to add pictures. That synced with the video. All right. Well. He magically appears. Boom.
He had free hair for a second.
Then he pauses for a little while. Then we go to cobalt. Copper. I go on and on.
I love this.
That's my video.
We need more of that. We want our lessons in that.
Your lesson.
I think we need to nominate you for an Oscar.
Like, seriously?
Who wrote the screenplay?
Yeah, we need a raise.
Can we like so like at the end? There it is.
We be in your next one?
Yeah.
Yes.
Please.
When I did this lab, I had the blue shirt student right here, right? So like I had all 3 of us in one video. Now, so I had video 1, video 2, and you can do like you can do as many videos synced up as you want. However, when I added like so there's a line right here. I tried fading it. You could see it on some of the pictures, but you can't. It's kind of hard to see here. There's a line right here. So when I added the third person, I tried to add a line right here and right here, but it cut off like that one part where it cut off his arm. It did that way too much. So he kind of disappeared in the lab.
I just like how he magically appeared right there.
What do you
Also,
really?
I feel like we all need to just come in class with all of our textbooks in one person.
That marks the conclusion of our fire drill.
Fuck,
Thank you for your cooperation. As mentioned before, we'll not be using the alarms for our drills. However, in the event that the fire alarm does go off, whether it be a false alarm or an actual emergency,
right.
we will exit the building as usual. Thank you.
That was a good fire alarm right there. All right, Landon, Tommy, Coy, Michael, Andrew, Keegan, Owen, Dylan, Josh, Cole, Nathan, Nick, Caden, Taylor, Aiden, Jake. Matthew is not here. All right. So, little entertainment for the start.
I love that. I want to be in the next one.
Just a little cloning. Yeah. Yeah.
No.
All right. So, what I did was I graded your quizzes. Overall, pretty good. I think the average was at 87. Pretty solid. Pretty solid. So I'm going to pass that back. I'm also passing back the free fall lab. A lot of people did pretty well on that. And I'll go over any questions you guys got.
What about the riddle?
What about the riddle?
What's the answer?
That's not really
Yeah.
a riddle. It's a joke answer.
Now, the biggest thing I took off at one point was there was a conversion from miles per hour.
So we didn't convert to inches.
I know. Way. I got it. Wait a second.
You didn't do this one.
Oh, I'll take a shot. Oh, yeah. Oh.
Oh, sorry. I thought this was no way.
It's not maybe.
You got it. Good job, guys.
I
can't go deep.
Landon. Matthew is not
I got a point on it. Oh my goodness.
All right. So I'm going to go over this quiz real quick. All right. Sorry about that. Anybody got an answer for my riddle real quick?
When the hell did Giants discover?
Yeah.
When the curve declines.
No.
When the health insurance discovered.
No.
When I am the point.
No.
I don't think you see
When
my
there's
doctor.
nothing wrong.
No.
When you eat an apple.
When a new apple orchard opens next door.
Not quite.
When you don't eat it. Does that have to do with apple?
No.
It's some kind of pun. It's a pun. If it's a pun, it's not a riddle. Yes, no. It's a riddle.
It's a joke, it's not a riddle.
It's a pun. It's a pun. I know it
Why
is.
you cook? Yeah.
Oh.
He's like, I know I can get this.
This has to do with your vaccines.
All right.
Anything.
So, gonna write some of this on the board. All right. So number one, as an object moves with a constant acceleration of 5 meters per second, which of the following is true? That answer is actually E. One is E. The object's velocity increases 5 meters per second each second. Okay. Because if it was either C or D, that'd be a lot. That would be meters per second squared per second. Yeah. So it can't be C or D. Number two, you have the cars. Okay. Now, what I saw a few people doing, so 0, then we have, I'm just going to do a car. 1 second, 2 meters, then 2 seconds, 8 meters, and then 3 seconds for 18 meters. Can you all see that all right? It's kind of blue. Do you want me to turn off mine? I'll turn it off. It's kind of hard to see. Now, what a lot of people did was they took the average velocity right here, right? 2 meters per second, 4 meters per second, 6 meters per second. However, from here to here, you actually traveled 6 meters in that 1 second. All right, here to here, how far did you travel? 10 meters in that 1 second. All right, and then here to here, you traveled 2 meters in that 1 second. So how much did you increase there to there? 4. How much did you increase there to there? 4 is your answer.
I did the equation.
Mr. Bowers, so
You can do the equation.
I don't know why that was so much.
So the equation you could have done was delta x, delta displacement, is equal to the initial velocity times time plus half the acceleration times squared. All right. Now, I know my initial velocity is 0, right? I'm not 0, so that gets rid of that. All right. Half the acceleration, I don't know what acceleration is. Time. Do I know my time? Oh, yeah, 3 seconds. Do I know my delta x? 18. Okay. And now you solve. 3 squared is 9. Half of 9 is 4.5. And you just divide by 4.5. And you should get 4. Now, a lot of people got 1 and 2 correct. Does anybody want me to go over that one? Those 2? A lot of, I think almost all of you got those 2 right. A lot of people got number 3 right. Now, I'm going to skip what number is that for you guys? I'm going to skip the A, B, and C question. I'm going to move to the very last one real quick. All right, and a lot of people got it right. Some people got it mixed up. You had to read the legend. The legend told you what Series 1, Series 2, and Series 3 were. Okay, there were 3 different cars. That was a little tricky, but a lot of people caught it. So let's talk about what number is that for you guys? Let's talk about number 4 real quick. I'm going to go over 4 and then we're going to move on. Okay, so in this problem, I know for A, I know my initial velocity is 15 meters per second. I know my gravity is negative 9.8 meters per second squared, which is your answer for C on that problem, which is your answer for C. And I know my time is 4 seconds. My goal is to find delta x. Okay. So the equation I used was delta x is equal to initial velocity times time plus half the acceleration times squared. Okay. So my initial velocity is 15 times my time plus half of negative 9.8 times my time squared. And that's how I got x. Does that make sense?
Why is that equal velocity?
Let's see. You threw the ball with an upward speed of 15 meters per second. Okay. And now to find I asked to find the velocity after 4 seconds. So the equation, acceleration, velocity final, velocity initial over time. Okay. So my velocity initial is 15. My acceleration is negative 9.8 meters per second squared. And my time was 4. All right. So you multiply 4 by both sides. Gets rid of that. And then add 15 to both sides to get rid of that. And that will get you your answer. Does that kind of make sense? Going over it kind of fast. Any questions on the A? That was A. Okay. And then B. Okay. So after solving those two things, I knew that now the maximum height, B says the maximum height reached from the point it was thrown. Okay, so my initial velocity state, acceleration, my time I don't know anymore because it's not my total time, it's just the time to get to the highest point. So I don't know what that is, right? However, what is my velocity when it's at its highest? When it's at its highest point, what's its velocity? 0, right? Its velocity is 0 meters per second. All right. So this one's a little tricky. You actually had to use the third equation. V final squared is equal to V initial squared plus 2AX. Okay. So my final velocity, 0 squared is 0, is equal to 15 squared, 225, plus 2 times negative 9.8 times by x. And when you solve for x, you should get 11.48. That's what I got. Okay. Do we feel all right on that? But like I said, the average was 86, I think. It was super awesome. Standard deviation was like 6.4. Not bad at all. All right. Pretty good. Any other questions you want me to go over? Awesome. Awesome. All right. You can put that away. All right. Now, holy smokes, we only got like 10 minutes left. Nah. That would be fun. That would be fun. All right. Let's see. Where was it? What I do want to do is I do want to talk about some slope here for a little bit. Say what?
This is in our notes.
Yeah. All right, just a little bit of graph. All right. I guess we're only gonna do this for like 6 minutes, and then we'll be done. Time flies when you have fire drill. Sorry, I've been making a rubber band ball. Kind of one of the most addicting things I've ever done. Like I can't stop making my rubber band ball.
Well, how does it balance?
I think we need to go outside.
Definitely test it out. Ooh. Now, if you analyze what I'm going to do up here, I'm going to show you. So my first bounce, I'm going to spin it to your right. Okay, it's going to bounce this way, but I want you to watch that second bounce. I want you to tell me why it bounced like that, right? So the first one goes this way, second one goes that way. You see the second bounce? So let's go that way. Wow.
advance the first time, I can see it start rotating in different direction. So it happens because of the first bounce, whatever it is.
Yeah. Kind of like a bouncy ball, right? Have you ever seen bouncy balls bounce like that? Kind of like goes in and out, in and out. It's kind of cool, honestly. All right. So I want to discuss some graphs real quick. All right. We know position time graphs pretty well. We kind of already did that. We had a lab about it. Where you guys ran. We went outside, we ran about it. All right. Now, is this? Let's see. Am I presenting right now? That would be a no. Present now. Entire screen. There we go. All right. So, if you look here, distance. Am I moving right now on this slope? No, I'm stopped. All right. Am I moving upwards here? At a constant velocity, right? Constant forward velocity. All right. Now this one, what's this actually doing? This is kind of what we've been talking about recently. Yeah, it's accelerating. It's accelerating. And this is actually going forwards, but it's kind of like we're hitting the brakes. We're still moving forward, but we're slowing down a little bit. All right. Let's see. Where are we at? There we are. Sweet. Down here it says decreasing positive acceleration. Just heads up. Okay. Those are position times. So hopefully that's kind of like a review. All right. Anything positive is going up. All right. Positive velocity. Now you can have a negative acceleration slowing down. You're still moving forward, though. All of these, you're moving forward. When would you be moving backwards?
If the graph had a negative slope.
Okay. You've had a negative slope going down, going closer to your home. And then if you keep going, you're going farther and farther away. All right. Everybody good on those? Next, instead of position time, so this is distance and time. We're actually going to be looking at velocity and time. Okay? It's a little different, but it applies all the same rules. All right? In velocity and time. All right? Let's see. All right? So when my slope is 0, am I still moving at a velocity? I still am. Just constant, right? So when the slope is 0, my acceleration is 0. All right? And when acceleration is 0, that's where it gets a little tricky. Because you can still be moving. You can still be, yeah, well, you'll see on the next one. All right, when your slope is positive, acceleration is constant. All right, slope is negative, acceleration is constant, but negative. Okay, using a lot of terms we've discussed before. All right, just applying it to a new type of graph. Everybody good? This is probably gonna be our last slide for the day. Or maybe we might get through one more. All right, so a stationary object. This is all 3 types of graphs combined. All right, so if object is here. This is how far it's moved. It's stopped. When it's stopped, my velocity is 0, right? And if my velocity is 0, then my acceleration versus time graph is also 0. All right? Whenever the slope is 0 on a velocity time graph, your acceleration is going to be 0. See, this has a slope of 0. Your acceleration also has 0. All right. Now, uniform motion. I'm moving 2 meters per second constantly, right? In a velocity time, I am moving, this is 2 meters per second, right? 2 meters per second, all right? Per second. But since that slope is 0, I am not accelerating. I'm still just moving 2 meters per second, right? That's all I'm doing, 2 meters per second. At this point, it's probably like 1 meter per second. Probably not even that. Well, probably meters per second. All right. Motion with a constant acceleration. Constantly accelerating. That's a little tricky. All right. So it's kind of an exponential form, right? Or function, I should say. All right. Now, if you're constantly accelerating, you're going to have a linear line, right? And then your acceleration is actually going to have a slope of 0 because it's constant. So when you're constantly accelerating, you're going to have a slope of 0. Does all this kind of make sense? We'll get some practice in probably next week. Okay. Now, just looking at this, there's going to be a lot of things that pop up. Pow, pow. That's a lot. All right. Yeah, I'll discuss this real quick. All right.
I have a question.
Yeah.
For like the graphs that don't have any line, is that 0 or would that just be like, what would the name of that be?
Like right here.
Yeah, would it just nothing? Would that just be?
Well, it's on the like on the x-axis.
Okay.
So yes, it's like 0. It's right. It's kind of hard to see, but that was a great question. All right. Now here, a lot of things. All right. If you're increasing your velocity, all right. Let's say this says at a constant acceleration. All right. You're increasing acceleration. All right. Or constant acceleration. That means your velocity time graph is going to be positive, straight line. However, when you get to acceleration, if that is a straight line, your acceleration is going to have a slope of 0. All right. So if your velocity time is constant, that's going to be 0 or a flat line. Okay. However, when you have a constant position time, if that is a straight line, your velocity time is going to have the slope of 0. And if your velocity time, that means you're not increasing or decreasing velocity. That means your acceleration is actually 0. Well, you can't see it, but it's at 0. Does that kind of make sense? All right. And then when you hit the top, you're coming down. All right. You're starting to get closer to home, closer to home. All right. And that's actually a negative, right? Negative velocity, which means your acceleration is going to drop down. Still a straight line, right? Does all that kind of make sense? Like, ish, a little bit. Okay. This is just intro. I will go over this more on Monday. I'll have some example problems we'll go over. Little activity we'll do, and we'll be good to go. Sound good? Awesome. You guys are awesome. All right. Sorry, don't have any more time for YouTube videos.
Good time for your YouTube videos.
Say what?
We gotta look for the cow.
Oh, yeah. Or the riddle. We get the answer to the riddle.
No, we didn't. We have not.
You have not.
Well, Matthew is here.
When somebody's being a pain, when they're sick of it, maybe? I don't know.
I think Katie found the cow.
I know that.
Oh, I can do now.
Ah,
So on my turn-in bins.
do you ever use those?
No, I did last year.
I got so much dust on them.
Here's the balance.
Yes.
Is your rubber band ball just all rubber band?
No, it's tennis ball. When the doctor runs out of patience.
That's a joke. That's a joke. That's a joke. We're still on.
So yeah, we're definitely still.
Matthew wasn't here, so also.
See ya.
Good morning, will Peyton Caputo please come in front receptionist desk?
The only teacher that has one of these, I have to do it here every day.
That's awesome. There you go.
Also, the only person that carried quick pencils before, I feel like.
That is also true, probably. Have a good weekend.
too.
Good morning, Mr. Hagan, please dial 4408. Mrs. Pinch, please dial 4408.